Good morning. I'm very grateful that you're starting your day with me this morning. I am from a different time zone, so my body is like, it's 2 in the morning, what the hell are we all doing up now? So it's very energizing to have other people also join in. So I'm Donella Montalion. And this is, as you may know, this is the non-Kotlin talk of the conference, right? That, as I understand it, there is always one, and I get to be that one today. We're going to talk about systems, basically, because increasingly, we don't just work in software, we work in systems of software. And so we're going to talk about why do systems work so well. So this is a question that Donella Meadows wrote the book Thinking in Systems, and for me it is a standard for understanding how systems work. It's not about technology, but much of it applies to our work. And she asked this question and came up with an answer. And I was inspired by this, and I like that we're going to explore this question because usually I talk about pain. I talk about all the pain that we are experiencing in our day-to-day life as a result of systemic pressures. I am going to sneak in pain today. That will happen. I wrote an entire book to try and alleviate the pain. But I wanted to challenge myself and us to think about what does work. What are we trying to do that can make a real difference? So to start with a little background, the person in the doorway, this is me. I started as a back-end engineer, which means that I helped build the monoliths that we are now trying to microservice. And I'm not sorry, because at the time, that was the right thing to do. But now I am a systems architect, which means all the words, event-driven, microservices, platform, although I'm not exactly sure that we have decided what platform means. But because it's so frequently used, I wanted to go to LinkedIn and just say, I'm a platform architect that does platforms with lots of platforms and platforms, because apparently that's the word. We're going to talk about what they really are. So in 2019, I was giving a talk at the O'Reilly Software Architecture Conference, and I was sitting at lunch, and a young man came and sat at the lunch table and saw my badge and said, oh, you're an architect. Now, I want to be an architect too, but I don't know enough about Kubernetes yet. And I first thought, oh, wrong lunch table, I'm really sorry where this is going to go. But also, I've worked on a number of big digital transformation projects, modernization projects, for organizations that you've definitely heard of, and they all ended up looking like this. So I've become very interested in why. Why do they all end up looking like this? And what I discovered is that, generally speaking, the core challenges weren't solved by technology, which means that I have had to expand my skill set into realms that I really didn't expect to go. And what I really want most days is to sit at my desk and think about Kubernetes. That would be really nice. But as complexity increases, and we've moved from building monolithic software to systems of software, then it brings up a whole different, not just challenges, but a whole different mindset. And so increasingly, this is what I talk about. And so what I want to confess is that I don't really like Kubernetes, and even if I could, it wouldn't be the thing that I would do today, at given time. It's tricky to talk about systems because it means that we are always going up and down the micro-macro scale. And not everyone wants to do this. Some of you might be allergic to abstraction and anything that sounds like abstraction, although what is Kotlin if not an abstraction layer over hardware and operating systems? So it depends on your definition of abstraction. But I spend a lot of time at the macro scale because I'm good at it and I like it and it has an impact. But also, today, here's what's on my mind is that for the first time, I'm building a monorepo using PNPM, which is new to me, and getting the packages for the theme components and the sanity queries to work across multiple apps where I have some control over Tailwind in one particular context, but also in a general context. And so trying to get the Vite plugin and Astro and these things all working together and communicating and figuring out which configuration I actually need and which of the 17 ChatGPT suggestions are actually going to break everything, which is pretty much all of them, is as much part of my day as the things we're going to talk about today. As a matter of fact, one of the things about being a systems architect is on the weekends, the thing I just said, that's fun, that's play. That's I get to rest my brain. So some of what I say today may not be your cup of tea. Totally fine. Not everybody needs to be a systems geek. What I would encourage, though, is to take away something that interests you, which means, because pain, something that really is pissing you off. Just really, really problematic for you day to day, just drives you crazy. And experiment with that, play with that, using some of the things that we're going to talk about today. Because we are, like it or not, all part of systems, designing systems, and impacted by systems. And so there will be something, at least, that can improve your working situation, even if it's a small thing. Because the beauty of up and down the micro-macro scale is that in systems, it's the small changes that scale to big results. You really don't have to do something big. You can do something small and have an impact. So as we go through today, thinking about how this talk may or may not relate to the other talks that you've been in, you'll find that they often complement each other. Yeah? Okay. I'll do one more confession. I didn't like JavaScript, and I thought JavaScript was a trend, so I didn't do much of it. I'm paying for that now. I was wrong about that. So whatever it is that you're avoiding doing today, learning, you might, don't be me. So let's start with this question, what do I mean by system, right? Because there are so many different context ways that we mean this, right? It can mean, a systems architect can mean someone who designs infrastructure, right? There are a lot of ways to approach our work, and there's a lot of different needs within an organization for what to think about. So this is one way, not saying the right way or the universal definition, because every context is different. But this is what I mean by systems and what it is that I focus on professionally. So a system is a set of interconnected components or parts whose relationships produce outcomes. This is very important. Notice I didn't say configuration. That a system is never the sum of its parts, it's a product of their interaction. So lately I've been saying I am basically a relationship therapist for technology systems. Which also means I'm a relationships therapist for human systems, because the relationship between, say, product and tech is what is designing the system. And you can't fix that with Kubernetes, right? And so when we're talking about systems, we are almost always talking about relationships. My favorite description comes from, again, from Donella Meadows, who says that you think that because you understand one, you must therefore understand two, because one and one make two. But you forget that you also have to understand and. And I would say that systems architecture, from my point of view, is the art and science of and. What does and give you that one and one can't do alone? So how do you know that you're in a systems context? So I'm going to give you 3 examples of situations that you might be experiencing now that would indicate to you that some application of systems design would be beneficial. So if you are designing data in motion, meaning you're not interacting with one giant MySQL database, but maybe it's a little bit more complex. You need to be thinking about coherence, meaning you actually can't control one linear delivery pipeline. There are parts that are interacting. There are things that are interacting with each other. The system has relationships across it, and those relationships can be good, or more likely, not so good, because they're not designed. Or you're optimizing. Here's the thing, I'm really sorry, but I'm kind of not sorry. That part of the talk is going to mostly say that you're optimizing for the wrong things. But at least you'll know what the wrong things are from a systems point of view. So data in motion, right? We were trained to think of data as a thing, right? A row in a database, a JSON object, something that has a home. But more and more, the data isn't just at rest, it is in motion. So data as a thing is tables. We think of tables, we store it, we query, we update, we think about where it is, we think about who owns this data. We use metaphors like vaults, right? Warehouses. But increasingly, systems today are event-driven, or they're reactive, or they're distributed, which means that the data is in motion. And we use words like emitted, transformed, mutated, because sanity has been my friend and enemy for the last month or so, aggregated. And we're dealing with challenges like concurrency, eventual consistency. And so data no longer just lives in its house, it moves, and it emerges through interaction. And so when this happens, when information is in flow, when knowledge is in flow, that is a systems context. And most failures don't happen in the code. It is such a good day. It's such a good day when something is broken in production and the problem is this line of code. And if I fix this line of code, I will fix the problem. But more often, it's an eventual consistency, right? And so that's not a bug as much as that is miscoordinated flow. The right information isn't available at the right time in the right place. Or an event doesn't communicate what it needs to communicate. So most failures aren't failures, they're data in a different context. So it's right over here, but once this materialized view has to make use of it, it's now wrong. So context matters, right? A cat bed. From my perspective, that's a cat bed that you see in the picture. But from the cat's perspective, it is not. My notebook is. This isn't a bug, this is feedback. This is saying that in this context, our views of what's needed, of what's necessary, are different enough that we that we're asking the same question, but we're coming up with different answers. And so people say, I'm going to say people say, they don't say, they freak out. People freak out. Oh my God, Diana, source of truth, source of truth, source of truth. Oh my, and fair, right? But truth isn't stored, it's emergent, it's contextual, like me and my cat, right? It's moving and based on interactions. So my geek way, systems geek way of saying this is truth is coherence across perspectives maintained through contextual feedback. Blah, 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 truth is asynchronous, right? Once you're in an asynchronous system, source of truth is also asynchronous. So the next thing is coherence. And what do I mean by you're designing for coherence? So this is what we've been taught as software engineers. We have been taught linear thinking. It is so familiar to us that we often just when we say thinking, this is what we mean. Rational, top-down, procedural, predictable, concerned with control. Well, we want these things, right? We want, this is why sometimes just putting on my headphones and working on a piece of code is relaxing in that if I do a thing, I get a response, and then if it's not what I want, I can change it. People, unfortunately, don't respond to me in that exact same way, and I don't find that as easy to deal with. So we can't build software without them, but they are not the end of the line. We're often architecting systems using the same approach. But in a system, the measure of how well parts of a system work together to produce the outcome that the system intended is what you're designing for. So think about this for a minute. That how well parts work together to produce outcomes. So a team is coherent if it functions well together, even as things change. They can handle uncertainty, right? A distributed system is coherent if you can change components independently, but the system still meets its goal. What I say is, if you can change parts independently and users don't know except what you mean for them to know, right? So the core thing is work together. Again, the and. So often we're designing one pipeline here and one pipeline here, but not thinking about how the two pipelines together in a system produce something that they can't produce alone. So this isn't a change in words, this isn't a vocabulary change, it's a change in how we understand software systems. And that what we're looking for is sense-making, as Dave Snowden talks about. Emergence. Emergence means two software parts are in relationship. If you build an API, they communicate. Do you get a third thing that neither of them can do alone? In a microservices architecture, we forget that's actually what we're trying to do. We're trying to have parts that work together to get something that you can't get from a single code base. Learning-driven, meaning when we push things to production, is the goal to go, let's see how this goes. Let's see how this works. Let's see what users do. Let's see what the world does. Let's see what happens. And being adaptive, meaning as you learn, can you change? Can you change without disruption? And it's about connection and flow, right? So we talk about data in motion. It's about being able to design flow in a system. So I want you to think for a minute about your current organization, what you'll re-experience again on Monday, and how would you rate these things? So, integrative purpose. How easy is it to make cross-functional decisions? How easy is it to have a business person, a product person, an engineer, an infrastructure person, security person in a room and actually come out with something impactful to do? Timely communication. Is it easy to get the information you need when you need it in order to be able to make a decision about how best to build what you're building? Are you able to give that information to other teams who might need it? And adaptive feedback. Do you learn from what happens? When you push something, when you make a change, do you know how to measure its impact in a way that's going to give you valuable feedback? So the thing is, this often isn't what we think about when we measure success of technology teams. But in fact, decades of system science shows us these are the things that will indicate whether or not innovation really happens, change really happens. So here we're at the hard cheese, the thing that you might least want to hear at Kotlin Conf, is that we're optimizing for the wrong things. And by this I mean that every system is designed to get the results it gets. Right? This is one of Deming's primary teachings and worth looking up. What this means is that the call is coming from inside the house. So the challenge is, and I'm going to go back to this for a second. Every system designs what it gets. So we think it's a tech problem or our logic is broken, but in fact, it's our core mental model. Systems behave how we expect. Systems don't behave how we expect, right? But that doesn't mean they're broken. They're not linear machines. So when I say the call is coming in from inside the house, what I mean is that we're designing systems as if they are linear machines, and we end up with this. That the way that what we optimize for shapes the system's structures, rules, incentives, how we hire, how we fire, what do we track, what do we reward, what do we sacrifice in order to get other things. So in systems, we use the iceberg model as a way of exploring this. I do this a lot in workshops, and it's really interesting what comes out of this. And what the iceberg helps us to think about is that what we value shapes our system. So what we believe, if we believe, for example, in developer productivity according to McKinsey's PowerPoint slides, then we are going to develop structures and patterns that manifest those ideas, those values, those beliefs. And we're going to end up above the surface, what's visible in production, as a result of those structures and patterns. But then we forget that we built it based on that idea, and we continue iterating without actually changing that core idea, challenging those core mental models. So specifically, nowadays, and especially when we think in a linear model, we think about efficiency, velocity, and control. How do we go faster? How do we be more efficient? And how do we make sure that we have lockdown power and control over everything that we push? Now, these are not bad things. They're just not everything. Donella Meadows says that efficiency is the enemy of resilience. And resilience is, as you'll see in a minute, one of those core system, healthy system properties. So these are the three qualities that when you have a healthy system, you know it because you can look at these three qualities and see that to some extent they are alive and they are vibrant. Resilient, self-organizing, and structure. And by structure, you're going to be surprised by the word I use when I describe structure, probably, unless you've already read ahead, in which case, no spoilers. If I'm saying you're optimizing for the wrong thing when you're not sure what your organization is optimizing for, it's probably optimizing for control. And optimizing for control exclusively is going to lead to frail and frail and bitter systems. I wanted to say brittle, but I think bitter. I think bitter's okay. I'm going to stick with that. So in a healthy system, you have certain capacities, things that you want to optimize for. So resilience, being able to absorb change without losing coherence, meaning stuff can happen, and that's just part of our life, part of our day. We adapt to it. There's a lushness to that. If you think about an event in a forest, unless it is a major catastrophe like a forest fire, and even then, a forest can recover. Self-organizing. So I didn't explain this because I think it's kind of fun to say this, knowing that you'll probably find it worrisome, make you wait, which is self-organizing is making the system structure more complex. I promise I'm going to explain that because it probably does not sound like a good thing, but it is. And hierarchy. Hierarchy is what I mean by structure. And it is reducing the complexity in a system by structuring relationships and the flow of information between subsystems. So we're doing this, right? If the idea behind monoliths to microservices, for example, is restructuring the boundaries in the system and the flow of information in order to reduce complexity. We just don't often think of that as hierarchy. So we're going to dive more into that. But fundamentally, the too long didn't read is that the right information in the right context at the right time. That the relationships in the system mean that you get the right information in the right context, structured for that context, when it's needed. Truth is asynchronous. So, qualities of a well-functioning system. Now, it's interesting to me that we're 26 minutes into the talk, and we are just getting to the things that are the title of the talk. But the challenge when you talk about systems, when you're trying to help an organization or a team or even your own mind understand, you're first switching context, because we use a lot of the same words that I'm using today, but we mean different things. My favorite example of this is Agile. If I'm in a bad mood and I just want to cause some trouble, I go in a meeting and just say that word, like a grenade. Watch what happens, right? Now, this isn't because agility is a bad thing. Agility is a good thing. Who doesn't want to be agile? It's that agile with a capital A experientially means pretty much probably something different to every single one of us in this room right now. So when I ask people who freak out, tell me, say more about it, they describe something horrible, something I would absolutely hate, as if Agile is responsible for climate change. Like it's really awful. But it isn't anything that I would call Agile with a small a, right? So often when we talk about words, we talk about them in the linear thinking model, in the rational, repeatable, predictable, top-down kind of way. But when you're talking about systems, that's never what you mean. So defining words together and developing a shared understanding of what we're talking about takes time. And I get impatient with that, so if you also get impatient with that, at least I'm not alone. But it is important to define words similarly so that you can talk about them, which I don't have to do if we could just be talking about Astro and mono repos and where I put the configuration and TypeScript making me crazy, but it's really just schema for JavaScript, which I'm very glad to have. And so if we can talk about these things to each other, we don't need as much context. But try and talk to the business person about them. You do need context. So always up and down the micro-macro level. So resilience, again, probably won't mean what's in your mind now. Let's see when we get to the end. So resilience is a systemic ability to change and or absorb shock, meaning to change on purpose or to change because you get forced to change. And getting forced to change is tech. Like, how many people here code in the exact same tech stack you did 10 years ago? I don't see any hands. 5 years. Ooh, a few. 1 year. About half. Okay, which means the other half is doing something you weren't doing a year ago. This is the world that we live in. We are always adapting and changing. We often get tested for a role based on what we already know, which is to me it's like buying a car that's already driven on the roads I drive on. But a car can go other places too, and we as knowledge workers are going to be constantly changing, and we're going to be constantly surprised by the impact of those changes. But it gets deeper. So it is a systemic ability that depends on diversity, redundancy, feedback loops, and well-designed interdependence. These are not the things that we generally connect with resilience. Usually when we talk about resilience, we talk about streamlining, we talk about productivity, we talk about pipelines, and we talk about throughput, and we talk about built to deliver, CI/CD, so that everybody can write code and it can be in production 3 seconds, and how can we do it faster? How can we write code faster? How can we push code faster? How can we lower time to first byte? Build? I never remember what the B is. Time to first, till people see things on it, right? How do we do that? Now, these are not bad things, but they do, from a systems point of view, impact resilience. Resilience wants things like redundancy. It's okay to have backups. It's okay to have other things running just in case. You don't know you need them till you do. And when you do, you're really glad that they were there, right? Slack. I do not mean the application. As a matter of fact, I mean the exact opposite. I mean time to think. I mean that we're knowledge workers. We need to focus. We need slack in the system to actually think about what's happening. When I say platform, what I mean is built for possibility, meaning it can meet emergent needs. I can spin up a new front end. It won't take very long for me to do that because the platform already has the capability of me asking questions and getting exactly what I need, as opposed to vomiting JSON all over me that came right out of some MySQL database, and I have to write regular expressions in order to figure out what it is I need. That would not be a platform. And also built to learn, as opposed to deliver, meaning feedback loops, right? And so the Alanis Morissette, we live, we learn, we make mistakes, we learn, we cry, we learn, right? That have we designed the feedback that we need in order to grow the system? So not just run hot, fast, and lean, but measured by the time to market, but measured by the impact. Did we have the impact that we intend to have? Did we change what mattered to change? Did we make the world better for the people that are using the system? Or worse, because some systems are evil, and they are in fact trying to cause harm, and I don't want to leave them out of the conversation. If they're an evil system, still, did you get more evil? So, an over-optimized system can be beautiful, but it'll collapse when a single node breaks. Just-in-time deployments. Great, but there's no buffer for failure. There's no inherent ability to respond to shock, right? And worse, this leads to the mindset of premature optimization. I really like saying that phrase, premature optimization. By this, I mean that we've made them fragile before we've even used them because we've over-focused so much on making them as lean and fast and efficient as we can. So in the US, I think this is universal, but it's a very big deal in the US, is all the layoffs. And who it is that we lay off. And what happens when you let go 50 people working on the infrastructure and then the site goes down. I actually heard this in the US. The site went down after a big layoff, and leadership blamed the deep state. You can use this. I've been using it. If I'm late for a meeting, deep state. Something breaks in production, deep state. It's a wonderful excuse, but it's not. I mean, if you lay off half the infrastructure team and the site goes down, that might be why, right? We also have a lot, as a result of all the layoffs, the silent quitting, the fact that many of us are burned out. And this means that the optimized human system is quietly failing, and that is absolutely going to lead to problems in production that we might not link back. So, like I said about speaking out in Slack, we need time to think. Having no time to think alone and with others hurts systems' resilience, right? If we're going in one single track, we don't have the ability to form relationships that are the core of how systems are actually optimized. And this is because the second quality of a healthy system is self-organizing, is the ability to self-organize. Now, we've heard this a lot. You've probably read articles about the importance of self-organizing. But I mean this as a systemic capability. So, natural systems, the cells in your organs in your body self-organize. So this is not we all going to feel good and be happy developers. This is actually something systems need to be able to do. And it's the ability to make its own structure more complex. So now we have the what, why. So first I want to say, complexity is the reality. The world is complex. Systems are complex. Everything is complex. If you're in a relationship or you're parenting, it's complex, right? There's complexity. There's a lot. It depends, right? Complication is when you basically can't make a decision, or the right decision, or the right information isn't available at the right time. We do not want to increase complication. That's noise in the system. Signal, the ability to actually focus on what matters, is what you're trying to accomplish. But we often, when we say complexity, we really mean complication. We really mean that there's a lot of noise. And that's not what I mean by complexity. Complexity is just, there's a lot of things impacting a lot of other things. That's just life. So what we mean by self-organizing, making the structure more complex, is that you can't generate resilience, you can't change, adapt, respond to growth if you have no ability to change the structures you're working in. You have to be able to change how you do things. So if you're in kind of a straitjacket of you have to focus on in one way, work in one way, then you're going to impact negatively resilience. Self-organizing is, for example, teams being able to shape their own process or work in concert with other teams. To some extent, load balancing, the ability to reroute, that is a form of self-organizing, right? Some failover to some extent, depending on how it's designed. Code that reacts to state, as opposed to put user in a specific state and make them stay there, right? So open source, when it is healthy and working, is a really good example of collaborative refactoring, the kinds of things that you get from self-organizing. Although even in those cultures, we tend to end up having the types of silos that we have in most organizations. But still, you can shift your approach based on feedback. And so systems evolve from within. Remember, the call is coming from inside the house, right? That self-organization is what happens when parts of the system actually listen to each other, right? When they understand their context, different from other contexts, me and my cat, and that you can adapt without waiting for permission. So we call this executive control, and that in technology cultures, and in most organizational cultures, in linear thinking, factory model cultures, executive control is what governs behavior. But only human systems do this. All natural systems, the way that things generally work, is that subsystems can function without the need for executive control, that executive control supports the behaviors of subsystems, not governs them. So basically what I mean is, the more able you are to adapt to your circumstances without a racy model, without some artifact with a signature on it, the more likely the system as a whole is to remain resilient and healthy. And this is why it matters. I love this from Zen and the Art of Motorcycle Maintenance, that if a factory is torn down, but the rationality which produced it is left standing, then that rationality will simply produce another factory. And I was having a wonderful conversation with one of the organizers before we started and talking about how trendy we are in tech and how I've been in tech long enough to know that things change, but they don't. We keep doing the same thing again and again, expecting different results. Now it's, hey, let's take the front end that we work so hard to decouple, to have separation of concerns and to have engagement logic here, let's put it back in the back end. Do you remember how you're not supposed to put inline styles in a MySQL database? Don't put web views in the back end. They're not really all that different. Now they are. Things emerge and change and we're learning, right? But we often think that we're doing something brand new and wonderful. And in fact, event-driven, message service bus, like we're often not, we're doing the same thing we've done before, just slightly differently. And so when you're designing systems, you will, at some point, have to challenge the mindset out of which the system's goals and power structures and rules and culture arises. This does not make me popular in meetings. And it's an especially challenge because if we look around the room, not a lot of people in this industry look like me. And so often I will hear, oh, that's because you're a different gender, a different age, it's because you started in PHP. This is the new thing. Because I was a PHP developer, apparently I'm ruined for life now. I know nothing. Like, you know what, though? I started in C++. And you know what I didn't like? I couldn't do anything. I mean, I could write stuff, local, whatever, but I had no impact in the world, right? At the time, the web was frames. It was HTML. It was a little bit of CSS, which I also didn't like. MooTools as a JavaScript library. That was fun. PHP meant I could do things. I could write software that you could use right now to do something. That is what brought me into tech. So I don't code in PHP anymore, but I will defend it until my death. And I'm starting to like JavaScript for the same reason, but just barely. It's like an X that I have to see at our kid's wedding, and I'm kind of okay with it now. So the thing is, I'm not randomly deciding to be here giving you this talk. Like, the world is changing, and it's constantly changing around us, and that the reality of systems is replacing whatever it is we thought we were going to do with software. Especially I work in information systems. And so if you think of things like the New York Times, for example, they were a newspaper when I started in tech. Imagine how much change of mindset has had to happen in those types of systems. Facebook still uses PHP. Therefore, that is what is wrong with the world. That is my thing now, is that any legacy software that's still running something it was running 20 years ago, deep state. So Larry Pruzak sums this up beautifully, that those companies that don't adapt to understanding knowledge as a force of production, you're not just pushing code, you're pushing your knowledge and your ability to get knowledge from other people to production. If they don't adapt, they'll slowly die and never know what killed them. This is pretty much every organization and team that I work with now is that they're trying to adapt to having a page-building, monolithic, linear system in a world that wants create once, publish everywhere. That wants, I want to ask Alexa for a question from something you think of as a large JSON object, but I only want one line. Which brings me to the function of hierarchy in systems. So hierarchy reduces the complexity that you get from self-organization by organizing it into subsystems. This is the most important thing. I don't mean silos. We do this by making silos. Silos are not subsystems. If you have a moat filled with alligators, metaphorically, around your team, that is a silo, not a subsystem. A subsystem has semi-permeable boundaries. In other words, you're still part of the system. So it doesn't mean control, encapsulation, PR approval, having root access. That's not what I mean by hierarchy. That's a responsibility, and then it's an important one, but not hierarchy. Hierarchy is the natural pattern in systems to form subsystems. The cells in your body do this with organs. People do this on teams. Functions. Functions, classes, these are forms of hierarchy. So we've gotten through this entire keynote so far without mentioning AI. I am very proud of this, and this is the only time I'm going to mention it because I use it, I think it's useful. Also, I hear so much stuff about AI that is complete delusion, just complete delusion, that I really hate even bringing it up in mixed company. But layers, the hidden layers, layering from a systems view is part of what we think of when we think of hierarchy. So closer to home, layered architecture in mobile, where you have the UI, you have a view model, you'll have a data source, a repository, maybe GraphQL if you're lucky or unlucky, depending on how your system is implemented, right? That type of layering is more what we mean by hierarchy. Composable. Composability is a hierarchy. I want my front end to be made up of components, not a thing that was stored in the database that I get fully formed, right? Package-based organizations, although honestly, building an app with 1,700 dependencies, packages, I'm not entirely convinced that's not a monolith, like putting modules and bunch of modules in Drupal. Is it decoupled, really? I don't know. This is my new question. Is it really decoupled, or are we just using a different thing? It is better, though. So layered and multifaceted is not how we generally think of knowledge. We think of knowledge as knowledge stock, the store of knowledge that you have developed or you can access. So our technology skills usually fall into knowledge stock, and they make us more efficient. Now, it sounds like I'm ragging on efficiency, but I'm not. I really like to be efficient, and I need to be efficient. It's just not the whole picture. And the flow of knowledge is more important than the storage of knowledge in systems, right? I think we've made that point to death. And so knowledge flow is your ability to transfer knowledge between people and within technology in a way that changes the system in the direction you want it to go. It makes you more effective. And so this question of how many of us work in the same tech stack, when we hire and we do a whiteboard test, the real question is, can you learn new things and adapt to new circumstances? And can you help others to learn what you already know? That would be the skill for knowledge flow, different from knowledge stock. We're always combining them, but this guy is not sharing knowledge, right? We love our opinions. I have lots of opinions. I made the mistake once of on stage saying, ask me about SAFe, and you'll hear all my opinions. But then people came up and told me stories about SAFe that weren't awful, terrible stories. So now I need something else to rag on. Was Kubernetes for a while? I don't know. I need a new enemy. But the point being, when we share our opinions, it's insufficient to help people understand how we came to that conclusion. I'm giving them my opinion, but I'm not sharing knowledge. I'm not showing what is it that convinced me that this was a good thing, so that they can think more deeply about it. So Peter Senge in the Fifth Discipline says that sharing knowledge occurs when people are genuinely interested in helping one another. Also not a big necessarily tech sometimes, but it can be a bit challenging to develop that in a culture, to develop new capacities of action, right? So not just a PR, but also how does your JavaScript do something that matters? Not just how does it work, how is it effective? And that we do this through learning processes. And again, notice collective ability, not 10x hero kind of thing. Collective ability, our ability to do this together. And that our ability to generate more resilience and self-organization and understand impactful actions, this is something that we do as just part of our daily life and our daily work. There's not, unfortunately, a checklist or a template for how to do this. It kind of boils down to being curious and somewhat friendly. I mean, think of it like breed of dog. Like if we were a breed of dog, we want to be something not fluffy, but not I'll bite your face off if you get near me, but something in between. Now, I have a French bulldog, which I thought would be the right thing, but that dog is so stubborn about everything that I stopped using him as an example. So what you're doing is you're synthesizing knowledge, experience, and sound judgment into recommendations based on valid reasons. So in other words, you're saying, here's what I've learned, synthesize other people's knowledge and experience with your own. Here's what I've learned about the relationships in this system. This is why I recommend that we do X. I considered Y and Z. This is why I ruled them out. That one little change from opinion to synthesizing and making recommendations based on reasons will have a tremendous impact on your career. I know that sounds crazy, but I've seen it again and again. Also, the reality is you can't build anything if you can't get money, and this usually is the path to getting people to give you money for your ideas. They don't pay you for your opinions, but they do pay you for your recommendations. But that's a side benefit. Little things you can do. So this is from knowledge management. Little things you can do that actually create good hierarchy, healthy structures in the system is socialization. Observe, share experience, share pain points. When I start with a team, the first thing I do is meet with people and ask them what sucks. What is horrible? Because I will learn more about the system if I ask people to tell me about their pain. You can structure activities like make models, make artifacts, prototyping. Prototyping is a wonderful way of developing knowledge flow and thinking together in a non-strictly focused on productivity way, but it often increases productivity because you get actually good answers. Synthesize and make sense. This is what I would call architecture, which means that you learn things, but also you're able to say, and so this is what we can do to make a really big difference. And put into practice what you learn from these experiences. I mean, fundamentally, I can know everything that there is to know about systems, but if I can't actually put anything into production that people can use, it's not particularly valuable. So it's always a combination of the micro and the macro, up and down, back and forth, doing a small thing, making a change, seeing what you learn, thinking about patterns and structures, going back to putting on your headphones. Always up and down. You can't do this alone. Remember that relationships in a system design the system. If you suck at business speak, partner with someone good. I'm terrible at visual design. I partner with designers who yell at me about my models until they're pretty, or at least better understandable. Partner with people who have skills that you don't have, makes you better because of the partnership. Works in microservices, and it works in people too. Requisite marketing moment. This was brought to you by my O'Reilly book. If this is your thing, it's available also on audio. Starting a second one now and do workshops. So if it's not your thing, cool. If it is your thing, there's more deeper dives that you can explore. Yeah? Okay. We have 5 minutes. I said we'd have 15 minutes, but I was wrong because I really wanted to talk about monorepos. But I think we would have time for a question if someone has a question. If we have a microphone for it. So let's start with that. We have 4.5 minutes. Does anyone have a question? I see people with. I can't see this. I never know what to do if nobody has a question. What do I do if no one has a question? Someone must have a question. Thank you for rescuing me. You can say it, and I can repeat it. Yes.
Yeah, I just have a question about Agile and the Agile transformation movement. What is your take on it?
Yeah, so I do a talk on Agile and architecture. So I have a long answer that I won't give. But the thing for me, when I started, I worked on Agile cross-functional teams, right? There are like 8 of us, and we made decisions about what to do. Management was about our career, but not about our process, right? We controlled the process. I didn't know that was unusual till I got out into the world. So my experience of Agile was the kind of thing you would usually want. That's not what everybody's is, right? So what happened is organizations used Agile to do exactly what Agile doesn't teach, like exactly the opposite of what it's supposed to do. So my answer is agility, the ability to self-organize, work cross-functionally, talk, like share responsibilities. These things are great, and I learned the things I need to know as an architect, I learned from working that way. So those qualities are really important, right? That kind of communication. At the same time, what people do, someone said, oh yes, we're hiring Scrum Masters so that they can assign tasks to engineers. You keep using that word. Don't think it means what you think it means. So if you are in a linear mindset, doing Agile is never going to work. It has to be self-organizing. So I like the qualities. As a process, I think we don't really know how to scale it. 1 more minute, so we have time for one more.
Hi there.
Hi.
Firstly, thanks for an awesome talk. The way that I view systems is that there's like lots of shared structure between places. Are metaphors often tools that you use in your day-to-day life, like trying to understand one system in sort of the terms of another system that may or may not have sort of shared behavior?
So I'm sorry, because I had trouble hearing. So the question is? The
question is, how valuable do you find metaphors in your line of work?
Oh, okay. These are my 2 favorite questions ever. I just wanted to know, you win all the question prizes. I was worried we wouldn't have questions. These are great. He asked, how important are metaphors? I can't actually describe systems without metaphors. This is why people are like, you're too abstract. But you can't describe relationships well with very linear language. So the challenge with metaphors is we don't actually mean the same thing. Especially, I use very American metaphors, and I'm surprised when people don't even know what I'm talking about because it's very US-centric, right? So what I like is finding a metaphor that we can use as shorthand to understand each other, and then get into examples of it actually happening, actually working. right? And that's hard. That's up and down the micro-macro scale. But a shared metaphorical language is a sign of a healthy cross-functional self-organizing team, right? That you have shorthands for things, for your pain and the good. So I think metaphors are great, but my metaphors fail as often as they succeed. They really have to be co-created. Might work for me, but it also has to work for you. Yeah? Well, the sky has opened up, so therefore, I think we are done. Thank you so much again this morning. Thanks.